You said, okay, Roger, be succinct. Give us the prevailing hypothesis as it relates to brain function alterations in alcohol and substance use, but keep it brief. I would say there's something wrong with reward learning. And you'd say, pass the exam. And reward learning goes back to Ivan Pavlov, 1897. He hit the bell and the dog salivated. And that brought us the whole world of classical conditioning, cue-based learning. I thought it was kind of apt to start that way because in many ways he's the father of the GLP-1s, which is interesting. So in 1897 he made this prescient observation that when you ring the bell, the dogs will salivate. But what he also reported is that when you ring the bell, the pancreas releases secretion. 5 years later, two people called Bayliss and Starling contested his hypothesis because they didn't think the way Pavlov thought. Pavlov thought that those pancreatic secretions were driven by the vagus nerve. And these investigators said, that's a bunch of nonsense. So they cut the nerve. And what they found was the pancreas continued to secrete different protein. So they sought to determine what this was that was causing the release of the pancreatic fluid. And they called it secretin. 30 years later, a guy called Labar, he said, I don't like that name, it's too non-specific. Because secretin could be the endocrine pancreas or the exocrine pancreas. So he dug deep, did his homework, and discovered that it was really the endocrine pancreas that was triggering release in the pancreas of other fluids. So he called it incretins. And then in 1970, Pedersen came along and discovered GIP, which is one of the proteins mimicked by Mounjaro and Zepbound. 16 years later, GLP came along. Of course, we all know that protein. So in many ways, you could link the discovery of the incretins, GIP, GLP proteins, way back to Pavlov as people contested his hypothesis as the origin of the pancreatic release. And he, of course, brought us classical conditioning.